Muscles contract or relax when they get signals from the nervous system or the motor unit, which is this whole thing. The signal is exchanged at this neuromuscular junction where the synaptic cleft and the sarcolemma connect. Muscle fibers are made up of myofibrils.
These myofibrils contain a unit that contracts called a sarcomere. Each sarcomere contains these alternating thick and thin filaments. This is what gives the skeletal muscle its striated look. Myosin, which is the thick filament, is anchored in the middle of the sarcomere called the M line right here. Thin are composed of actin, which is the thin filament, which anchors on this Z line, which is this squiggly black line. Because the actin filaments are anchored to the Z line, the sarcomere shortens from both sides when the two filaments slide on each other.
The action that occurs between the actin and myosin is described as sliding. These myosin filaments actually grab onto the actin and they will pull it like so. They will grab this and they will pull it in that direction. These contractions begin when ATP, which is inside of these heads of the myosin, or the thick myosin, when they hydrolyze into ADP and inorganic phosphate. This is what causes the myosin head to extend and grab onto that. It attaches to these binding sites, which are these little black dots on the actin, and allows the myosin to pull the actin towards the M line, which is this right here, but it's going to be in that direction. The result of this pulling motion is going to be a shortened sarcomere. Muscle contraction is controlled by calcium because it opens up these binding sites.
When the neurotransmitter, which contains the chemical ACH, molecules are released from this neuron, and it allows calcium to travel to the actin.
Now this flow of calcium is called the action potential, and when the calcium opens up those little stores, it allows the sodium and potassium to flow through.
And it goes through the sliding motion, which makes the muscle contract. And the entire sarcomere shortens, causing the entire muscle.